So if it's differentiable, it's continuous. But if it's continuous, that doesn't necessarily mean that it is differentiable, right? You still have a corner or a cusp or a vertical tangent line. Okay, so this is saying that it's differentiable. So it's continuous and differentiable on this interval. The mean value theorem says that you can find the average rate of change on that interval, which is 55 minus this 55 over 2.8 minus 0.3, which is 0. And so that tells us that if the average rate of change of the velocity on the interval was 0, that somewhere on the interval, the instantaneous rate of change is also equal to 0. So you'd use the mean value theorem to indicate that. Does that make sense to everyone? People at home, you good with that?
Yeah.
Great. People here, you're good with that? All right, then we want to use a trapezoidal sum 3 subintervals to approximate the value of the integral from 0 to 2.8 of v sub p. So if we're going to do that, first thing we do is we look and see if these subintervals were all of equal length. Right? If they're all of equal length, then you could just use the trapezoidal formula. You don't have to find the area of each individual trapezoid. So 0 to 0.3 and 0.3 to 1.7 are not the same, are they? So unfortunately, you have to find the area of each trapezoid. So that ought to be base 1, 0, plus base 2, 55, divided by 2, times the length of that interval, which is 0.3. And then you would add to that the next one, 55 minus 29 over 2, times the length of that interval, which is 1.4. And then plus the next one, which would be negative 29 plus 55, divided by 2, times the length of that interval, which is 1.1. Everybody good with that? And then you have a calculator, so you just arithmetic on your calculator. And what did you get? 40.75? Is that what you said? Yeah. Yeah? People agree with that?
Yeah.
Yeah? One yeah, one nodding head. Cool. Any questions on part B? All right. We have a second particle, particle Q, and they give us its velocity. We want to find the time interval during which the velocity of Q is at least 60 meters per hour. Okay. So all we have to do then is figure out when is this thing greater than 60, right? So when is 45 root t times the cosine of 0.063 t squared greater than 60? So what I would do is I would just say, I'm just going to write it this way. Instead of writing the whole Q of t, we want it to be greater than 60. So really we're interested in when is that function minus 60 greater than 0. So I would graph this function and see when it's above the x-axis. And what is the interval that you found for that to be above the x-axis? Yeah. Nope. These are the bases. These are the heights of each of the trapezoids. From here to here, here to here, and here to here. The things being added together are the y values in the trapezoidal sum. Those are your bases. Those are the height of the function, which represents the bases. Yeah. Anybody get an interval there for part C? What'd you get? 1.866. So what? 3.51. Good enough. Yeah. People agree with that interval?
I use my calculator to solve the interval for me. Do I need to can I just write?
That's what you should do.
Okay, can I just write what you wrote and then do using the graph and solve it that way?
Yeah, I would just write this, and then I would say if v, or if t is on this interval, that'd be good enough.
Perfect.
Is that the interval you got?
Yes, it is.
Wonderful. That's confirmation to what Riley said, since nobody in here nodded their head about that one. All right. Find the total distance traveled by the particle when the velocity is at least 60. So how do we find the total distance traveled? That's right. We integrate. What do we integrate? What? So to find total distance traveled, normally we integrate the speed, right, which is absolute value of velocity. But in this case, we know that the velocity is more than 60, so we know that on this entire interval, the velocity is positive. I'm going to write absolute value of v of t, just because that's technically what you're doing. You're taking the integral of the speed from the total distance traveled. But in this case, the absolute value is unnecessary. Yeah. 1.866. Yeah. Sorry, my handwriting is atrocious. I don't know. I don't know what to do about it. And what that value come out to be? 106.108. 109. Everybody agree with that? Yeah, Layla, you're good with that one? That one you agree with? Anybody else agree with that one? Yeah, we got 3. All right, 3. That sounds good to me. All right. Any questions on part C?
Yeah, since it says at least 60 meters per hour, couldn't the velocity be 60 meters per hour? So wouldn't you have to use whatever brackets instead of parentheses?
Yeah, I suppose that'd be better. At least 60. We'll put those in brackets, yeah. Somebody asked me about why I use the mean value theorem again in part A. So for part A, I use the mean value theorem because it's asking about why must the derivative of something equal a certain value. And so really the only way that we've ever talked about why the derivative of something must be a specific value is using the mean value theorem, where the average rate of change on the interval has to equal the instantaneous rate of change somewhere on the interval, or it has to equal the derivative somewhere on the interval. Does that make sense or no? So we found that the average rate of change between 0.3 and 2.8 was 0, which is what we wanted it to be. So that means that the instantaneous rate of change, or the acceleration, had to be 0 on that interval. Is that good?
Yeah.
Okay. All right. Part D. At t equals 0, particle Q is at a position of x equals negative 90. And we want to, let's see, use our result from part B and the function v sub q to approximate the distance between the particles P and Q at t equals 2.8. So we need to find the position of both particles at t equals 2.8. So part B gave us the distance that particle P moved, right? It moved 40.75 units. That's the displacement of it. And it started at 0. So we'll say that particle P is at 40.75. Particle Q ought to be at its initial position, negative 90, plus its displacement from 0 to 2.8, right? 0 to the final time, 2.8. And its displacement ought to just be the integral of its velocity, which is v sub q of t. And what did you guys get for negative 90 plus the integral from 0 to 2.8 of v sub q of t dt? 5 point what? 5.188. Other people agree with that?
Yeah.
Yeah? Great. And so then the distance between them is just whatever 40.75 minus 5.188 is, which is what? 35 point something? what is that? 35.5. What is that? I can do arithmetic. 588. That's not right. 587. 587. No, that's not right either. What is it? I don't know. I can't do arithmetic. What's the difference between 40.75 and 5.188? Something with a 2 at the end. That doesn't make sense either. I can't do arithmetic. Nobody subtracted that and got a final answer?
Oh, 5.562.
562? That makes sense. Yeah, 560. What's the matter? Your difference was
distance.
5.188? You told me the wrong thing. Does that sound better to everybody?
Yeah, and then we subtracted 40.75 from that.
And your difference was 5.188. Okay. All right. Everybody good with that? Okay. Any questions or issues with that one? We feel reasonably okay about the motion problems? The more of them we do, the better we're going to get them. So we did this one last time, right? We did this one last time. This was the next one I said to do. Yeah.
Yeah.
What just happened there? All right, for t greater than or equal to 0, we got a particle moving along the x-axis. They're given its velocity and its position at t equals 4. We want to know, is the particle speeding up or slowing down at t equals 4? So speed is increasing if, no, well, yeah, if the derivative of speed is, but derivative of speed is annoying to find. If what? Yeah, if velocity and acceleration have the same sign, it's slowing down. If they have opposite signs. This is an important thing to remember, right? If V and A, velocity and acceleration have the same sign, it's speeding up. If velocity and acceleration have the opposite signs, it's slowing down. So V of 4 is what? 1 plus 2 sine 2, which is what? Okay, so positive. And then acceleration at 4, have your calculator find the derivative of that and evaluate it at 4 for you. What do you get? Negative 1 point what? 164. Okay. Clearly they have opposite signs. Everybody agree with those two numbers? Yeah. Opposite signs means slowing down. Yeah. No, that'd be fine. If you put in an absolute value and take the derivative, that'd be fine.
Why would just knowing that the acceleration is negative not be enough to prove that it's slowing down?
Because we're talking speed, and remember that speed is absolute value of velocity. So the reason this whole thing up here is true is the answer to your question. So we think about velocity being positive means we're moving to the right. And if the acceleration is positive, right, this is V is positive. If the acceleration is positive, that means that the velocity is getting larger, which means that this thing is speeding up, right? If the velocity is positive, but the acceleration is negative, that means my velocities are going from like 10 to 9 to 8 to 7. They're getting slower, right? So it's slowing down. If my velocity is negative and my acceleration is positive, that means that my velocities are going like negative 10 to negative 9 to negative 8. And since speed is the absolute value of that, if I take the absolute value of those, that tells me that I'm going from 10 to 9 to 8 in terms of velocity, which is slowing down. One second. And then if my velocity is negative, but my acceleration is negative, that means that I'm going from -10 to like -11 to like -12. But when I take the absolute values of those, I go 10, 11, 12, and it's speeding up. So it depends on if those things have the same or the opposite signs, whether the speed is increasing or decreasing. Does that make sense?
Yes.
Wonderful. Okay. Right. What was your question, Ryan? Oh, yeah. Sorry. 2 squared. I didn't square it. Yeah, I think somebody just told me the right value. 2 sine 8. Yeah. All right. Everybody good with part A? Four squared is 16, not 4, huh? Oh well. All right. Part B, find all times t in our interval 0 to 3, where the particle changes direction. So we want change in direction. Change in direction means that velocity either goes from positive to negative or negative to positive. So we need to figure out when is the velocity equals 0. So we'll say v of t is equal to 0. At what values? You use your calculator to find when that's true. Yeah. What values of t made the velocity 0? 2.707. Any other ones? You just found one. Anybody else get more than one? Not on the interval. Okay, perfect. Yep, sounds good to me. So one place. And does the velocity go from positive to negative, or does it go from negative to positive there? It goes from negative to positive. So it goes from negative to positive at t equals 2.707, which tells us the particle stops going to the left and starts going to the right at that t value. And so you'd write out on the AP test, v of t equals 0 at t equals 2.707. You'd say change in direction because v goes from negative to positive. It's not enough to just say that the velocity is 0 there. You have to indicate that there was a sign change of the velocity, because the velocity could have hit 0 and then stayed positive, or hit 0 and stayed negative if it was already negative. Does that make sense, everyone? Did you have a question, Karina? You looked like you were going to ask a question, but then you didn't.
Yeah, well, I said that the velocity changed sign, but I didn't negative positive.
It's always nice to indicate which direction, but it's not, if you didn't write from negative to positive, that's fine. Just so long as you made the indication that it changed signs, not just that it was equal to 0 at that point. Everybody good on that distinction, though, that you have to indicate that it changed signs, not just that it was 0 at that point. Because things can touch the x-axis and bounce off of it, right? Like y equals x squared does that at 0, right? That's okay. All right, good? Good. Part C, find the position of the particle at t equals 0. So position should be the initial location of it plus the displacement, right? Like we've been talking about. We are given an initial position of 2 at t equals 4. So 2 plus an integral from 4 to whatever value that we're looking at. What's the value we're looking for? 0, right? So 2 plus the integral from 4 to 0 of v of t dt. And your calculator will evaluate that for you. What did it come out to be? Negative 3.815. Everybody agree with that? Serena, yeah, you agree with that one? Yeah. Any questions on that one? Yeah.
Do we have to like change the limit or
You can do 4 to 0. That's fine. Yep. Normally, when we evaluate it by hand, we like to just flip them to the lowers and the bottom, but your calculator is just going to do that itself anyway. Yeah. Everybody good there? And then, question. How do I know it goes from negative to positive? Talking about back in part B. You just need to look at the graph of it. So, 1 second here. What was the velocity function? 2 plus sine of t squared over 2? Or 1 plus sine of 2 squared over 2? 1 plus 2 sine. Like that? Yeah? Yeah? Oh, you can't see it. 1 plus 2 sine x over 2. Yeah. So you just look at the graph to determine that it's going from negative to positive. What was it? Or positive to negative, sorry. 2.707, the graph goes from positive to negative. Didn't you guys say it went from negative to positive? Somebody said it went from negative to positive, didn't they? I don't remember who that was. It goes from positive to negative. Yeah. I don't remember who said that, but right? Derivative goes from positive to negative. Yeah. So yeah, that's how we determine. I guess I should have looked at the graph and not trusted people. Positive and negative. Everybody get that? Yeah. 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 Everybody at home good with that?
Yeah.
All right. Okay. Part D. What was part D asking? Total distance it travels from t equals 0 to t equals 3. Total distance should be easy. Total distance traveled is just the integral from 0 to 3 of the absolute value of velocity. And your calculator will tell you exactly what that is. You don't need an initial condition because it's total distance traveled. What do you get? Anybody? 5 point what? 301. Other people agree with that? Yeah? Serena agrees. Anybody else? Just the two of you? Riley, is that what you got? Bummer. 0 out of 9. You'll do this one tonight? Should be really easy now that we've just done all of the parts. All right, everybody's good with that? Anybody at home have any questions on that one? All right. The good news is after we do number 5 here, the one about jogging on the straight path here, I was going to have you guys do number 6, and I was going to show you how to do number 6, but Riley has already completed number 6, so we can let her show everybody. I should be really excited about that. All right. So actually, I don't think I'm allowed to let you go to the board. I don't know. Maybe I'm not. Maybe I am. Who knows? We'll see. We'll just have you tell us everything about number 6. All right. So we got Joanna is jogging on a straight path. Or I guess Johanna. I don't know. Something. She's jogging on a straight path. And we've got selected values of v of t. And we want to use the data in the table to estimate v prime of 16. So to estimate the derivative of something, the best thing you can do is find the average rate of change. 16 falls directly between 12 and 20, so we'll just do the average rate of change between those. 240 minus 200 over 20 minus 12, which ought to be 40 over 8, which ought to be 5 meters per minute. Is that really the units? The V of t is measured in meters per minute? Okay. Oh, that was 30. All right. Cool. I guess I'm okay with that. Everyone good with part A? Pretty straightforward there.
I know. I have
What?
a question.
Yeah.
I know it's pretty minor, but on the actual test, if you were to not put the meters per minute in the answer, would they dock points?
You would be fine on this particular one because it does not say indicate units of measure or something like that. So here, in part B, using correct units, explain the meaning of it. So if it says using correct units or indicate units of measure, there is a point associated with units. If there is not, then there is not. If it doesn't say that, there is not. Always safe to put it just in case, but you would be fine if you just wrote 5. Everybody good there? Okay. All right, using correct units, perfect. we're going to explain the meaning of the integral of the absolute value of v of t from 0 to 40. So this is the integral of speed. So an integral of speed should be a total distance traveled. So this should be the total distance that she travels. Actually, she's not running, is she? She's jogging. We don't want to say she was running. She was just jogging. Not that that matters. Jogs in, what is it, 40 minutes? In the first 40 minutes. And we would say measured in meters, right? Because the integral of that absolute value of velocity is a total distance, which is meters. Everybody good there? Then we want to approximate that value using a right-Riemann sum with the 4 subintervals. Are the subintervals all equal? 0 to 12 is 12. 12 to 20 is 8. So not equal, so we have to find each one separately. Starting at the right endpoint, 150. So 150 times the length of this interval, which is 16, plus, am I using negative 220? No, I'm using positive 220 because it's the absolute value of velocity. Times this interval, which is 4, then plus 240 times the next interval, which is 8, and then plus 200 times the next interval, which is 12. And based on your amazing arithmetic skills, what did you get for that? 7,600 meters. Everybody agree with that? Yeah. Good. She's jogging fairly quickly. Now, I guess it's not that fast. What is 7,600 meters? That's like a little less than 5 miles. 1,600 meters to the mile, about. Everybody good with part B? Any questions on part B? Yeah, that's good. All right. Part C. Bob is riding his bicycle along the same path. Bob's velocity is modeled by this b of t function. We want to find his acceleration. So finding his acceleration ought to be easy, right? Because we're given his velocity. B prime at 5 should be 3t squared minus 12t at t equals 5. What does that come out to be? 15? They were really happy with us for getting that right. Any questions there on C? Everyone's good? Yeah? Okay, cool. People at home, you're good with that?
Yeah.
Wonderful. All right. Part D, find his average velocity. How do you find the average of a continuous function? Using the mean value theorem for integrals. So what did it say on the time interval 0 to 10? So 1 over b minus a times the integral from a to b of Bob's velocity. And what was Bob's velocity equation? It was t cubed, so that's going to be 1/10 at the beginning, times t to the 4th over 4. And then minus 6t squared ought to become minus 2t cubed. And plus 300 ought to become plus 300t. And we're going from 0 to 10. Everybody good with that? So we have 1/10 of 10 to the 4th over 4 minus 2 times 10 cubed plus 300 times 10, all minus 0, because all those are 0. And I didn't do my powers of 10 here. I don't know why, but this then becomes when I divide everything by 10, I can drop all those powers of 10 by 1. So 10 cubed is 1,000. 1,000 over 4 is 250. This becomes 10 squared. So that's just 200. This just becomes 300. And what do we end up with? 350 meters per minute. Good or no? Did it ask us anything else about it? Just find his average flow. Any questions on that one? How do we feel in general about motion problems? Good enough that you could take the quiz tomorrow? Not good enough that you could take the quiz tomorrow. So we should do some more of them. Yeah, okay. You want to do a train or a particle? Non-calculator, calculator? To do particle,
Calculator.
non-calculator. What? Calculator?
I said calculator.
All right, calculator it is. That's perfect because Riley hasn't done this one. All right. What do we got? We got plenty of time, right? Yeah. All right, I'm going to give you guys 15 minutes. We'll do this one, and then I will assign a few more motion problems for tomorrow for us to go over if we have time after the anti-differentiation multiple choice. So we're going to do this one first. Calculator, 15 minutes. Setting a timer. Ready? Go. Wait, I didn't set the timer. Go. Part A, we want to find all time intervals when the speed of the particle is 2. So we're talking about speed of the particle. So all we need to do is figure out when the absolute value of velocity is 2. So graph the absolute value of that function and graph y equals 2 and see where those two things intersect. Or graph the absolute value of the function minus 2 and see where it has x intersects. So what did you guys get for that? Looks like I found the scoring guide here for this one. Looks like it should be 3.128 and 3.473. That sound good to everybody? Question? I'll make v of t equal to 2 and negative 2. Yeah, that's fine. Yeah, that works. Anybody, any questions on that? That was work. 2 points. Everyone good with that? Part B, write an expression involving an integral that gives the position. So, and then we want to use that to find the position at 5. So we know that the position is the initial position plus the displacement, right? So our initial position is 10 plus the integral from 0 to, we'll just say whatever t value we want on the interval 0 to 5, right? Of negative 2 plus, well, we'll just say, we don't even need to write the whole thing out. We'll just write the x. Right? So 10 plus the integral from 0 to t of the velocity function. And just make sure you write this in terms of a different variable so that you can put a t up in the upper limit. The integral of the absolute value is the total distance traveled. So somebody's asking, what is the integral of absolute value of v? The integral of the absolute value of v of t is the total distance traveled. Speed is the absolute value of velocity. So you don't need to take an integral to find speed. Speed is absolute value of velocity. The integral of speed is distance traveled. Does that answer your question? Yeah. All right. So then we need to evaluate this at 5. So we want 10 plus the integral from 0 to 5 of v of x, which is about what? Looks like that came out to be negative 9.207. Y'all agree with that value? 2 points for part B, 1 for the integral setup with the 10 plus, and 1 for negative 9.206. Question?
1.5, like, can you get back to the
It'd be fine. I don't think they'd dock you for that.
If you've already put in your equation into your calculator underneath the y equals screen, is there a way to copy and paste it into the equation screen just so you don't have to retype it out?
Not to my knowledge.
Well, that's stupid.
Sorry. You could. The what?
is that what you want?
I don't know. Maybe. Karina says there's a way to do it. Karina is going to very loudly tell you what she thinks is the way to do it, so you can hear her.
When you're trying to get the equation from what you graph to like the equation screen or whatever, like trying to take the integral of it, if you press the button that says VARS, like a calculator, like variables, and then I think it's function, like if you press enter, then it says function, and then like it'll give you a list of like y1, y2, y3 or whatever, and then you just like press y1 or whatever your equation is in. And I think that did it. I don't know. Did that work, Nick?
I heard VARS and function. Those are the only two words I can make out.
If you press if you press VARS, then you like
Push VARS.
then you go to the right,
Then go to the right.
and you get y variables, and
Then there's Y variables.
Thank you. I got it now.
Then you press enter. Is there any more to it?
I figured it out. We're good. Thank you.
Then you press enter again. And then what? Then you have it. VARS, go to the right. Y function, press enter again. Got it?
Yep.
Great. Look at that. There's a way to do it. All right, any other questions on part B? Or any other questions for Karina on how to use a calculator? Look at that, I learned something new today. It's fun. All right, part C. We want to find all times t when the particle changes direction. So first thing we need to do for part C is look at when v of t equals 0. And we could graph it. I'm not going to draw the graph, but it equals 0 at t equals 0.536 and 3.318. And we would note that at t equals 0.536, it goes from negative to positive, and 3.318 goes from positive to negative. You don't need to note that it's negative to positive or positive to negative. You just need to note that there is a sign change in the velocity at those points. So make sure you write, right, it equals 0 at these points, and both of them have a sign change of velocity, so this is where it changes directions. If you want to specify negative to positive and positive to negative, that's great, but you don't have to specify which direction. Good or no? And make sure you check for the sign change, because sometimes there might be, 2 or 3 values, but one of them, it touches the x-axis and bounces off. It doesn't actually cross through. So make sure you verify that it actually crosses through. Everyone good there? That one was worth 3 points. And then part D, is the speed of the particle increasing or decreasing at t equals 4? So remember that speed is increasing if the velocity and acceleration have the same sign, and it's decreasing. I say increasing. Speed is increasing if they have the same sign, and decreasing if they have opposite signs. So At 4, we'll find v of 4, which I don't think we found any other time, did we? What's v of 4 come out to be? Negative 11.476. And then you would find v prime of 4, which is a of 4. And that comes out to be negative 22.296. And since both of those are less than 0, we would say velocity and acceleration have the same sign. Speed increasing. Everybody good with that? And that was worth 2 points. Any questions or issues with that one? All right. So tomorrow we are going to do the anti-differentiation multiple choice. That may or may not take the whole period. If it takes the whole period, fine. If it doesn't, then we will move on and do some more of these motion free response questions. So I would like you to complete number 5, which is the train problem. Riley, you've already done that one. Good job. Nice work. So number 5, and then let's see. This one's number 7. Let's do 5, 7, and 8. So the train, and then this non-calculator particle one right here, number 7. And then Ben on his unicycle, 5, 7, and 8. The train, the particle, and the unicycle. Oh, is that, sorry, 6, that's 6. Sorry, 6, 8, and 9. Not 5, 7, and 8. 6, 8, and 9. Train is number 6. Is that right, Riley? Yeah, train is 6. 6, we just did 7. 8, and 9. 6, 8, and 9. Everybody got that? 6, 8, and 9? 6, 8, and 9. People in the Zoom, you got that? 6, 8, and 9? 6, 8, and 9. 6, 8, and 9. 6, 8, and 9.